Okay class, welcome back. Today we are going to quickly introduce to you net ionic equations and teach you how to write them. My objective for you today is that you would be able to write a net ionic equation by the end of this lecture. In saying that, let's dive into what we got today. Okay, before we dive into the practical portion of this lecture, let's clear up some verbiage that I will be using throughout this video and future videos. An aqueous solution is a solution in which the solvent is water. A complete ionic equation is the molecular equation that separates the molecules into their ions. Spectator ions are ions in the reaction that do not undergo any change. Finally, our net ionic equation is the molecular equation that depicts the ions or molecules that experiences changes in charge or changes in oxidation. Okay, now we got this terminology out of the way. Let's dive into the meat of this lecture. As we stated, a net ionic equation is an equation that depicts only the molecules or ions that are actively involved in a reaction, or those that undergo change. In these types of equations, spectator ions are not present. Because of this, it makes it easy to see the active molecules in this reaction, because they are the only one present within the equation. Net ionic equations are also useful to see exactly what changed throughout an equation. The first step to writing net ionic equations is to balance a chemical equation given it is not already balanced. So, if we mix sodium chloride with silver nitrate, we would have this reaction. NaCl aqueous plus AgNO3 aqueous yields NaNO3 aqueous plus AgCl solid. Next step, we would write a complete ionic equation for the aqueous compounds. Notice I said aqueous. If a component is solid or liquid, they must stay in its molecular form. The complete ionic equation for our sodium chloride and silver nitrate would read the following. Na plus aqueous plus Cl minus aqueous plus Ag plus aqueous plus NO3 minus aqueous yields Na plus aqueous plus NO3 minus aqueous, and then we have plus our silver chloride as a solid. Notice we didn't set that into any oxidation states. Finally, we can write the net ionic equation using the complete ionic equation. To do this, we just cancel anything out that appears on both the product and the reactant side as the same. So in this case, our sodium 1 plus ion and our nitrate 1 minus ion would cancel out, leaving us just with our net ionic equation of Ag plus 1 aqueous plus chlorine minus 1 aqueous yields AgCl solid. Let's work another one so that you have some practice with this. Let's say I have lead 2 nitrate, so PbNO3 2 aqueous plus potassium iodide aqueous, which is Ki, yields PbI2 plus potassium nitrate. PbI2 is a solid while potassium nitrate is a aqueous solution. Once we balance this out, we get 1 PbNO3 2 aqueous plus 2 Ki aqueous yields PbI2 solid plus 2 KNO3 aqueous. After seeing that this is balanced, we can split our aqueous substance into their respective ions, so lead 2 nitrate would break down into Pb plus 2 aqueous plus NO3 minus 1 aqueous. Our potassium iodide would break down into K plus 1 aqueous and I negative 1 aqueous. Finally, our KNO3 would break down into K plus 1 aqueous and NO3 minus 1 aqueous. This would give us a complete ionic equation of Pb plus 2 plus NO3 minus 1 plus K plus 1 plus I minus 1 yields PbI2 solid plus K plus 1 aqueous plus NO3 minus 1 aqueous. Now we just cancel out both sides. What is the same? This means I would cancel out my nitrate negative 1 aqueous forms on both sides and my potassium plus 1 on both sides. This should give us a net ionic equation of Pb plus 2 aqueous plus 2I minus aqueous yields PbI2 solid. In conclusion, class, net ionic equations are going to play a vital role in determining the electron transfer in later videos. Today we learned how to calculate net ionic equations. We're going to take this knowledge and continue to use it in later topics, so keep it in your back pocket. And saying that, keep up the good work, and see you next time.